YARN is the acronym for Yet Another Resource Negotiator. YARN is a resource manager created by separating the processing engine and the management function of MapReduce. It monitors and manages workloads, maintains a multi-tenant environment, manages the high availability features of Hadoop, and implements security controls. Before 2012, users could write MapReduce programs using scripting languages such as Java, Python, and Ruby. They could also use Pig, a language used to transform data. No matter what language was used, its implementation depended on the MapReduce processing model. In May 2012, during the release of Hadoop version 2.0, YARN was introduced. You are no longer limited to working with the MapReduce framework anymore, as YARN supports multiple processing models in addition to MapReduce, such as Spark. Other features of YARN include significant performance improvement and a flexible execution engine. Now let's discuss YARN with the help of an example. Yahoo was the first company to embrace Hadoop, and this became a trendsetter within the Hadoop ecosystem. In late 2012, Yahoo struggled to handle iterative and stream processing of data on the Hadoop infrastructure due to MapReduce limitations. Both iterative and stream processing were important to Yahoo in facilitating its move from batch computing to continuous computing. After implementing YARN in the first quarter of 2013, Yahoo installed more than 30,000 production nodes on Spark for iterative processing, Storm for stream processing, and Hadoop for batch processing, allowing it to handle more than 100 billion events such as clicks, impressions, email content, metadata, and so on per day. This was possible only after YARN was introduced and multiple processing frameworks were implemented. The single cluster approach provides a number of advantages, including higher cluster utilization, where resources unutilized by a framework can be consumed by another. Lower operational costs, because only one do-it-all cluster needs to be managed. Reduced data motion, as there's no need to move data between Hadoop YARN and systems running on different clusters of computers. The YARN infrastructure is responsible for providing computational resources, such as CPU or memory, needed for application executions. YARN infrastructure and HDFS are completely independent. The former provides resources for running an application, while the latter provides storage. The MapReduce framework is only one of the many possible frameworks that run on YARN. The fundamental idea of MapReduce version 2 is to split the two major functionalities of resource management and job scheduling and monitoring into separate daemons: YARN and its architecture. In this topic, we will discuss YARN and its architecture. 3 elements of YARN architecture. The 3 important elements of the YARN architecture are Resource Manager, Application Master, and Node Managers. The Resource Manager, or RM, which is usually one per cluster, is the master server. Resource Manager knows the location of the data node and how many resources they have. This information is referred to as rack awareness. The RM runs several services, the most important of which is the resource scheduler that decides how to assign the resources. The application master is a framework-specific process that negotiates resources for a single application, that is, a single job or a directed acyclic graph of jobs, which runs in the first container allocated for the purpose. Each application master requests resources from the resource manager and then works with the containers provided by node managers. The node managers can be many in one cluster. They are the slaves of the infrastructure. When it starts, it announces itself to the RM and periodically sends a heartbeat to the RM. Each node manager offers resources to the cluster. The resource capacity is the amount of memory and the number of vCores, short for virtual core. At runtime, the resource scheduler decides how to use this capacity. A container is a fraction of the node manager capacity, and it is used by the client to run a program. Each node manager takes instructions from the resource manager and reports and handles containers on a single node. In the next few screens, you will see a detailed explanation of the three elements. The first element of Yarn architecture is Resource Manager. The RM mediates the available resources in the cluster among competing applications with the goal of maximum cluster utilization. It includes a pluggable scheduler called the Yarn Scheduler, which allows different policies for managing constraints such as capacity, fairness, and service level agreements. The Resource Manager has two main components, Scheduler and Applications Manager. The scheduler is responsible for allocating resources to various running applications, depending on the common constraints of capacities, queues, and so on. The scheduler does not monitor or track the status of the application. Also, it does not restart the tasks in case of any application or hardware failures. The scheduler performs its function based on the resource requirements of the applications. It does so based on the abstract notion of a resource container that incorporates elements such as memory, CPU, disk, and network. The scheduler has a policy plugin, which is responsible for partitioning the cluster resources among various queues and applications. The current MapReduce schedulers, such as Capacity Scheduler and the Fair Scheduler, are some examples of the plugin. The Capacity Scheduler supports hierarchical queues to enable a more predictable sharing of cluster resources. The Application Manager is an interface which maintains a list of applications that have been submitted, currently running, or completed. The Applications Manager is responsible for accepting job submissions, negotiating the first container for executing the application-specific application master, and restarting the application master container on failure. Let's discuss how each component of the Resource Manager work together. The Resource Manager communicates with the clients through an interface called the Client Service. A client can submit or terminate an application and gain information about the scheduling queue or cluster statistics through the Client Service. Administrative requests are served by a separate interface called the Admin Service, through which operators can get updated information about the cluster operation. In parallel, the Resource Tracker Service receives node heartbeats from the Node Manager to track new or decommissioned nodes. The NM Liveliness Monitor and Nodes List Manager keep an updated status of which nodes are healthy so that the scheduler and the Resource Tracker Service can allocate work appropriately. The Application Master Service manages application masters on all nodes, keeping the scheduler informed. The AM Liveliness Monitor keeps a list of application managers and their last heartbeat times to let the resource manager know what applications are healthy on the cluster. Any application master that does not send a heartbeat within a certain interval is marked as dead and rescheduled to run on a new container. Before Hadoop 2.4, the Resource Manager was the single point of failure in a Yarn cluster. The High Availability, or HA feature, adds redundancy in the form of an active standby Resource Manager pair to remove the single point of failure. Resource Manager HA is realized through the active standby architecture. At any point of time, one of the RMs is active and one or more RMs are in standby mode, waiting to take over should anything happen to the active. The trigger to transition to active comes from either the admin through the command line interface or through the integrated failover controller. The RMs have an option to embed the Zookeeper-based active standby elector to decide which RM should be active. When the active goes down or becomes unresponsive, another RM is automatically elected to be the active. Note that there is no need to run a separate ZKFC daemon, like in HDFS, because the active standby elector embedded in RMs act as a failure detector and a leader elector. The second element of Yarn architecture is the application master. The application master in Yarn is a framework-specific library which negotiates resources from the RM and works with the node manager or managers to execute and monitor containers and their resource consumption. While an application is running, the application manager manages the application lifecycle, dynamic adjustments to resource consumption, execution flow, faults, and it provides status and metrics. The application master is architected to support a specific framework and can be written in any language. It uses extensible communication protocols with the resource manager and the node manager. The application master can be customized to extend the framework or run any other code. Because of this, the application master is not considered trustworthy and is not run as a trusted service. In reality, every application has its own instance of an application master. However, it's feasible to implement an application master to manage a set of applications. For example, an application master for Pig or Hive to manage a set of MapReduce jobs. The third element of Yarn architecture is the node manager. When a container is leased to an application, the node manager sets up the container's environment. The environment includes the resource constraints specified in the lease and any kind of dependencies, such as data or executable files. The node manager monitors the health of the node, reporting to the resource manager when a hardware or software issue occurs, so that the scheduler can divert resource allocations to healthy nodes until the issue is resolved. The node manager also offers a number of services to containers running on the node, such as a log aggregation service. The node manager runs on each node and manages the activities such as container lifecycle management, container dependencies, container leases, node and container resource usage, node health and log management, and reports node and container status to the resource manager. A Yarn container is a collection of specific set of resources to use in certain amounts on a specific node. It is allocated by the resource manager on the basis of the application. The application manager presents the container to the node manager on the node where the container has been allocated, thereby granting access to the resources. Now let's discuss how to launch the container. The application manager must provide a container launch context, or CLC. This includes information such as environment variables, dependencies on the requirement of data files or shared objects prior to the launch, security tokens, and the command to create the process to launch the application. The CLC supports the application master to use containers. This helps to run a variety of different kinds of work, from simple shell scripts to applications to a virtual operating system. Owing to Yarn's generic approach, a Hadoop Yarn cluster runs various workloads. This means a single Hadoop cluster in your data center can run MapReduce, Storm, Spark, Impala, and more. Broadly, there are 5 steps involved in Yarn to run an application. First, the client submits an application to the resource manager. Then, the resource manager allocates a container. Then the application master contacts the related node manager. Then the related node manager launches the container. And finally, the container executes the application master. In the next few screens, you will learn about each step in detail. Users submit applications to the resource manager by typing the Hadoop jar command. The resource manager maintains the list of applications on the cluster and available resources on the node manager. The resource manager determines the next application that receives a portion of the cluster resource. The decision is subject to many constraints, such as queue capacity, access control lists, and fairness. When the resource manager accepts a new application submission, one of the first decisions the scheduler makes is selecting a container. Then, the application master is started and is responsible for the entire lifecycle of that particular application. First, it sends resource requests to the resource manager to ask for containers to run the application's tasks. A resource request is simply a request for a number of containers that satisfy resource requirements, such as the following. Amount of resources, expressed as megabytes of memory and CPU shares. Preferred location, specified by hostname or rack name. Priority within this application and not across multiple applications. The resource manager allocates a container by providing a container ID and a hostname, which satisfies the requirements of the application master. After a container is allocated, the application master asks the node manager managing the host on which the container was allocated to use these resources to launch an application-specific task. This task can be any process written in any framework, such as a MapReduce task. The node manager does not monitor tasks. It only monitors the resource usage in the containers. For example, it kills a container if it consumes more memory than initially allocated. Throughout its life, the application master negotiates containers to launch all the tasks needed to complete its application. It also monitors the progress of an application and its tasks, restarts failed tasks in newly requested containers, and reports progress back to the client that submitted the application. After the application is complete, the application master shuts itself and releases its own container. Though the resource manager does not monitor the tasks within an application, it checks the health of the application master. If the application master fails, it can be restarted by the new resource manager in a new container. Thus, the resource manager looks after the application master, while the application master looks after the tasks. Hadoop includes 3 tools for Yarn developers: Yarn Web UI, Hue Job Browser, Yarn Command Line. These tools enable developers to submit, monitor, and manage jobs on the Yarn cluster. Yarn Web UI runs on 8088 port by default. It also provides a better view than Hue. However, you can't control or configure from Yarn Web UI. You will see a demonstration on Yarn Web UI in the later screen. The Hue Job Browser allows you to monitor the status of a job, kill a running job, and view logs. You will understand this by viewing a demonstration in the later screen. Most of the Yarn commands are for the administrator rather than the developer. A few useful commands for developers are as follows. To list all commands of Yarn, type the command line shown on screen. To print the version, type the command line shown on the screen. To view logs of a specified application ID, type the command line shown on your screen. Using Yarn Web UI, Hue Job Browser, and Yarn Command Line. In this demo, you will learn how to work on Yarn Web UI, Hue Job Browser, and Yarn Command Line. You will use the file wordcount.py, which is a Python file. This file will calculate the number of times each word appears. You will view how to execute this file with the help of Yarn. Type spark-submit. Let's define the master as yarn-client, followed by the name of the Python file. You need each word count which is present in the word directory loudacre/kb. Click Job Browser. While the program is running on the terminal, let's see how the steps executing in Yarn appear in Hue. You will notice the Python word count status as running. It will also show you the status of map and reducer. Click ID. You can also click on ID option to view more details of a job. You can also click on Kill option to end this job from UI. Once you enter the application ID, you can view the running metadata of that yarn. In this page, you can also view the information such as start time, end time, and the amount of memory per second that a running program consumes. Let's go back to the terminal. You can check similar details in Web User Interface, which you just viewed from Yarn Resource Manager. You need to navigate to localhost:8088/cluster. You will again notice the running ID. Click this ID to view more details. You will be able to view information such as user, name of the program, application type, current state of the running program, and a few additional information. You can also scroll through the accepted jobs, currently running jobs, finished jobs, and a few more details. So, this is another Web UI page in which you can monitor your Yarn progress. Once this program is complete, you can view the output in the terminal. It displays the number of times each word appears. This brings you to the end of this demo. In this demo, you learned the steps to calculate the word count for a file. You have also learned the steps to monitor your Yarn progress in a web user interface.
Hey, want to become an expert in big data? Then subscribe to the Simplilearn channel and click here to watch more such videos. To nerd up and get certified in big data, click here.